here we are solving for x. Let's see, we have some students online. Sunif, can you tell me what would be the first step?
Factor the first term.
Okay, so if I factor this is the difference of square, so it would be x minus 5 times x plus 5. And then what do you do next?
I'm not quite sure. I would say add the second term.
Yeah, it looks like you can add this to, but would be an easier method. Every time you have an equation involving fraction, there is a method to eliminate the fraction. Anybody know what is that? Joshua, do you know how to eliminate fraction? Was that no? I didn't hear you.
I'm sorry, what was the question?
What's the first step here? What do we do to solve for x? What do you think?
Multiply LCD.
Very good. You find the LCD. That's your next step. So LCD here would be x minus 5 times x plus 5. Joshua, what do you do? What do you do with this LCD?
You would multiply your 3 over x plus 5. You'd multiply that by x minus 5. And then 1 over x minus 5, you multiply x plus 5.
Okay, but that's one way to do it. That's a long way. You're trying to add this to. We've just decided to not add this. Instead of adding this to, I want to eliminate all these fractions. I want to know if anybody know how to do that with the LCD that I have here. So let's see who else has a microphone here and can help us here. Let's see. We have Sierra. Sierra, any idea?
You multiply it to the top.
Right, you multiply each term by that. That's what you do. If I look at the LCD as x minus 5 times x plus 5 over 1, the next step is to multiply each term by that. So please make a note of that. Every time you have an equation involving fraction, you find the LCD among all of them, and then you just simply multiply each term by that. And that would guarantee to reduce all the fraction. So the first term here I have is 10 over the LCD here. And then the second term is 3 over x plus 5. So I'm going to multiply this also by the LCD. And remember why we're doing this. We're doing this to eliminate all the fractions here. And then here we have plus 1 over x minus 5. So I'm going to multiply this also by the LCD here. So which would be again x minus 5 times, it's going to write up here, x plus 5. Okay, the next step is to reduce them. So reduce the fraction. So here we get x minus 5. X minus 5 reduces to 1. X plus 5. X plus 5 reduces to 1. And so on. All these fractions turns to 1. So let's see. Sunit, can you tell me what do we get for the first term to the left side of the equation now?
10.
Yeah, we just get 10. Very good. Equal to, continue, what do you get for on the right hand side?
3 times x minus 5 plus x plus 5. I mean, is it?
Right, yeah, we were supposed to reduce this correctly. So this should be a minus, so we reduce the minus, not plus. Yeah, you're right. So let's go ahead and do that correctly. I just, this would be my, yeah, 1, here we go. So you're right, it would be x plus 5, very good. Okay, so you're right. So on the left-hand side, we get only 10. On the right-hand side, we get 3 times x minus 5 plus, and then x plus 5 because x minus 5 reduced here. So as you see here, this equation here is equivalent to this equation here. So it would be a lot easier to solve this now than what we had earlier. Now before I continue solving for x, there are some restrictions here for x. There are some values that I cannot assign for x, because if I do, I would cause these fractions to become undefined. Can somebody tell me what are those values that I cannot have for x?
5 or negative 5.
Right, very good. I cannot let x equal to 5, because if I let x equal to 5, then this whole thing becomes 1 over 0, and that would be undefined. So you want to make a note of that at the beginning of the problem, that x minus 5 cannot be equal to 0, and therefore x cannot be equal to 5. That's one restriction we have here. And for the other part, x plus 5 also cannot be equal to 0, so x cannot be equal to negative 5. So we're going to keep this in our mind here. So if I get x equal to plus or minus 5 at the end, then I cannot include those as our real solutions. So let's go ahead and continue with this. Let's distribute this. Let's distribute this to solve for x. I get 10 is equal to 3x minus 15. And then if I distribute this plus 1 here, I get plus x plus 5. So here on the left-hand side, I get 3x plus x would be 4x. And then these two numbers would add up to minus 10, equal to 10. So if I continue here, if I add 10 to both sides of the equation, then I would get 20 is equal to 4x. All right, Joshua, can you tell me what this x is equal to here?
X equals to 5.
20 over 4, which is equal to 5. And we said earlier we cannot have x equal to 5. Right here, that was one of the restrictions. So it means, what would be the solution to this? Samit, what is the solution?
Undefined.
Well, we find one solution to be 5 using this method, and we said 5 cannot be a real solution. So actually, we have to say no solution. That should be the answer. Okay, so the answer to this would be no solution. No solution for this equation. So we could have no solution, infinitely many solution, or one solution when we solve for equations. So in this case, just turns out to be no solution. So once again, to reduce equations like this involving fraction, we find the LCD, multiply each term by LCD to make this look like a linear equation, and then we can solve for them. Don't forget to include the restrictions at the beginning of the problem, so if you find the solutions is one of those restrictions, we exclude them as part of our final answers.